Okay, so we are assigning you this EOC practice on the actual program that you're going to take the test over so you can check out the tools. In the meantime, these are the questions that you had in an EOC practice test. And I'm going to go over the ones that are difficult. And you're just going to put those answers into this practice test, but also understand how to use the tools. So anytime you see something like this, you need to make everything on the same side of the equation. So I'm going to subtract 3a and add 3. So subtract 3a, because that's my like term, and add 3. So he's gone here. So I'm left with a 2a squared plus 5a and a negative 12. Now, punching this into Desmos is not going to work because we're looking for these factors. So I need to multiply these two together and then find the factors of this. When added together is going to give me a positive 5a. So 1 times 24 is not going to do it. 2 times 12, 3 times 8, ooh, that's going to give me 5. 4 times 6, no. So this here, I'm going to add my a's to it. To get to a 5a, my 8 would be positive, my 3 would have to be negative. So I'm going to do the two factors here, positive 8, and then bring down this guy, and then group. So grouping, we've done this on Alex. My GCF here is a. I'm going to take out that a, and I'm left with 2a minus 3. If I take out a 4, which is my GCF, again, I'm left with 2a minus 3. I'm going to, these are the same, so I can take that out as a common. When I take these out, what am I left with? A plus 4. And those are my two answers. It can go fast once you start getting the hang of it. Your next question on this program is, I know you don't like to read and it sometimes confuses you, but sometimes just looking at this, you can understand it. So all it's asking, is this increasing or decreasing? Well, it's increasing. The function is linear, quadratic, or exponential. I don't know. So I've got some gaps to fill in here. So this should really be 0, 1, 2, 3, 4. So if I try to fill in those gaps, I can see I increased by 15 here. So to get to 2, I decreased to make this 30, or add 15 to 15 to get 30. 15 minus 15 is going to give me a 0. So you can see this is constantly increasing by 15. This is constantly increasing by 1. You do have to fill in the gaps, looking for those patterns. So it's repeated addition, so that's linear. My y-intercept is when x equals 0. You could graph these points if you wanted to on your graphing paper. So 115, 345, and then graphed it with your straight edge, and you should have gotten 0, 0, or see it here. The next one. We just did this in Alex. So what you're doing is you are adding your exponents. So 1/3 plus 1/4 in your calculator gives me 2/7. I just lied, that's not 2/7, Mrs. Spiro. 7/12. And make sure you are adding that. So 7/12 should be added. So this one right here. Sorry, I was looking at this word and I saw that. But you're punching that into your calculator. You're just adding those, same base. Next one is probably my least favorite one. So here, it says to take that and times it by 2. So 2 times 2 minus 1 is 3. So my y-intercept would be 3. So here it is, and that is B. Next one. We've talked about this. This one obviously is the best trend line. It's in the middle. Okay. Next. Oh, okay, these are x and y values. So you're just substituting these in. This is your x, this is your y. So you would say -2 times -5 plus 5 times 0. Does that equal to 10? If it does, if it's true, you put an X there. If it's false, you leave it blank. So you're just looking, you're substituting these values in to see if they're true. This next one, you would say y is equal to 2 times 3. And what's my x value? Negative 5. Does that equal 0? Because my y should have been 0. If it's true, then you're fine. If it's neither, then you would put an x there, substituting those values in. So I really want you to actually do that one and to find the answers. Okay. Next one. What can be inferred here? So let's take a look. All that applies. The mean is equal to the median. No, because when this is skewed over here, your mean is really here. That's your mean because of the skew. So the mean is equal. The mean is probably less than. That's true because it's skewed. The mean is probably more than. No. If an officer captures an additional 70 miles per hour, does the mean change or does the median change? Well, the mean changes. Anytime you have an outlier, the mean changes. This one here. The easiest thing completes the square. This one's actually kind of hard. And we really did not have a chance to get into this because it was bizarro. This one is the only one where you're going to subtract the 13. Subtract 13, and then you're going to square. You're going to take this guy here, divide it by 2, and then square it. It's called squaring, completing the square. Like you're ever going to remember this, right? So that's 5. That actually means 5 squared equals 25. So obviously, you're going to add, not obviously, but it's going to be obviously this is where they're coming in with this 5. But what you need to do is add 25 to both sides. And since this is a positive 25, it would be a positive 25, and negative 13 plus 25 is 12. So it's going to be that one. I know, pretty bizarre. All right, so let's look at this. What do we know about these guys? These guys are your roots. So my roots are 2, 0, and 4, 0. So when you're looking at these and we were trying to find our roots, we were setting them equal to 0. So if I made this one to 0, that would make this a positive 2, add 2 to both sides. And this one I would add 4 to get the 4, positive 4. So that's what you're doing, this one. Okay. Is there another one? Probably. We are looking at doing like this kind of thing on here. What you could do is distribute that, because we know that's true. So this times this times this. X squared minus 4x, this times this times this times this, negative 2x, and a positive 8. Okay, simplifying this one, so it's going to be that one. Again, I understand I'm going fast, but sometimes you guys need to know fluently and quickly and know some of these clues. Next, graph this. Oh my gosh. You guys should know this one. So this, here's a point, here's a point, here's a point. Don't care. Y equals, what's my slope? I'm going up 2 over, see, up 1, 2, over 1, 2, 3. To my left, so it's negative. What's my y-intercept? 5. There it is. This one is the hardest one. So this just means that your x values need to be between 0 and 60. So that's here, your x values. So 10, 20, 30, 40, 50, 60. You can do it that way. Make a table. So if your x value was 10, 20, 30, 40, 50, 60, and then I substitute these values where the x is, so negative 3 over 2 times 10 plus 120. What's my y-intercept? Or I'm sorry, what are my ordered pairs? Well, in this case, let's see here. So negative 3ABC2 times 10 plus 120 gives me 105. Okay, that's my lowest. Is this going to be higher? So let's do this guy so we can kind of get our increments. So same thing times 60 plus 120 equals 30. All right. So my lowest number here on my y is going to be 30, and I need to go to 105. So maybe we could go up by 10s, go up by 20s. Let's go up by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. You do not, sometimes they will limit you, so you've got to be careful. So, and then actually on this one, you can graph the first one and the last one and connect them. So this first one would be 10, 105. So 10, 105 is here. My last one is 60 and 30. Is this 1, 2, 3, 4, 5, 6? I just want to make sure. And 30. And I'm just going to do those two. Take my straight edge, connect them. Here's my line. And I do have a y-intercept, so if I wanted to go up to 120, I could. It's probably a good idea since it's there. We should have known that because that's that right there. That y-intercept, 120. Didn't even pay attention to that, but we were right on. Always label this x, always label this y. Has no other information, so there's nothing else I can do here. Next, car sales. So I'm going to use like a straight edge, and think about it the best I can. It's going to go through here. So what do we know about this? We know the temperature gives no indication of car sales. No. As this is increasing, so is this, right? So this, not true. This, if temperature is 50, okay, so let's go up here. My temperature, they're going to sell about 4 cars. Well, that's false. The higher the temperature is correlated to higher car sales. That's true. This says the same thing. One says causes the car sales to increase, and the other one does not cause. So does one really cause somebody else to buy a car? No. If the weather is nice, it does not make them buy the car. So that's what you have to think. When you think of the cause, does the temperatures really cause you to buy a car? So it would be D. Next. We should be professionals at this. Okay. I think when I looked at this, they all had, this is your y-intercept. So all of this was correct for all of these graphs. And basically it was just the shading. So this first one with the -2 as your y-intercept, let's look at this on all of them. It is the straight line, and this is less than. So I'm just going to go to this one. Less than literally means down here. Okay, so that leaves this guy out. It also leaves B out because it's not below. This one here with the dotted line says it's going to be greater, so shading up here. So between that, which one is shaded in both directions? So that's this part right here, and that would be D. Next one. Okay, so if Riley needs money, the amount here must be greater. Okay, I know this is kind of flip-flopped around, and this is why this one, I'm not 100% like this one either. It's because you have to save more than the 300. You really have to think about that. And then I need to solve that. So 310x plus 75, subtract the 75. That gives me 225, divide by 10, divide by 10. So that divided by 10 gives me 22.2 is less than x. So my x has to be greater than 22. So that would leave me 23. A few more. Next one. Here, make sure you understand when you see this, it's telling you X is the t-shirts sold. So I always say 15X is t-shirts. Minus 25 equals, we'll make that Y. Y is your profit. This equation, this is your profit. This is the equation that came up with for the profit. All right, so what is true if X was 200? So Y is equal 15 times 200 minus 25. So whatever this answer is your profit. And that is this right here. That is your profit. Understanding those equations. Next one, functions. A function is no repeating x values. So are any of these x values repeating? Yes, so that's not. Are any of these repeating? So he's good. If I do my vertical line test, this one's good. If I do my vertical line test, he's not good. Anytime you have a linear equation in slope form, that's linear. So your equation's going to go up like that. So therefore, that is a function. Next, we did these before, but we're going to go over this. So look at your pattern. So here we are what? Dividing by 2 each time. Okay. Here is like that palindrome. So it goes to one, goes to the other, repeats, and then goes up. So it's got that palindrome. So it's got that look, which is quadratic. This one, I think you are, I was trying to remember what this one is. What is 4? I think that's 4.5. And this is 5.5. They just kind of made it tricky. So you're decreasing by 1/2. So minus 1/2 each time. Repeatedly. So minus 1/2. This one, you are probably, I'm just going to look at here. So from here to here, I multiplied by 2. I'm multiplying by 2 each time. Okay. So exponential decay, that's repeated division. You're dividing. So that one would be f of x. So this goes here. Exponential growth would be the repeated multiplication. So that's k of x. Linear is repeated adding or subtracting. So that's h of x, and quadratic is the g of x. Almost done. Which of the following statements describe this? So the number of days missed has no correlation. Well, obviously there's a correlation here, so that's not true. A student with perfect attendance, so this is perfect attendance, right? No school missed. They get about 98. Well, I'm thinking that's pretty true. A student with perfect attendance is supposed to get 38%? Don't think so. For each day a student is absent, it increases. So we are looking for kind of the slope. So we'll go from here to here. So what is that slope? Approximately. So we're going up by how many? So from here to here, what is that, 98 did we decide? So this is what, about 88? So we increased by 10 and 2. So we increased about by 5. So for each day a student is absent, the scores to decrease 6 percentage points. Well, 5 and 6 is pretty close. For every 6th day a person is absent, the score decreases by 1%. That's not true. It decreased a lot between here and here. So there you go. Sorry, I know this is getting kind of weirdo. Let's go ahead and graph these two. So a +3, I'm going to go up 2, sorry, I'm going to go down 2 over 1, which is super annoying because I would actually do this on your own graphing paper before you answer this or put it into Desmos. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So you can see how precarious this is because it's so small, and it's simply silly that they did this in such a weird way. Okay, so the next one, we started here, and we're going to go up 1 over 2, up 1 over 2. Okay, so this one we can clearly see that the answer is, what does that say? 2, -1. Okay, or you can put both of these equations in Desmos and see where they intersect. Hope I did that right. Okay, we didn't hit this a lot, but I'm going to think about my, yowza, it's still increasing. This one's decreasing. This one is goodness knows, but it seems to be, I don't know. Okay, so this one, if you're at a +1, that means it's a really good. So where's the closest positive? That's this one. This one's also increasing, but it's closer to not so good, so that would be closer to 0. So, but it's still positive. So a -1 would be a really good downward. So this is closer to -1, and this is just hideous. Oh, and we're done. There you go.